We started this project in 2007. We had 5 major streams coming into Durham, and all of them were in violation of water quality. Basically, the water lands on our campus in parts of Durham, and essentially all that fertilizer, biochemicals, residue, runoff, it's all going to New Hope Creek, which is all going to Jordan Lake. I've done restorations all over the world. Why not restore these streams and wetlands on the Duke campus? This is a bird blind. It was built actually by the students. An MEM class actually built this. It's been a great tool for classes and for research. A number of master students, a whole group of projects. You slow it down, sediment sinks, and you build up floodplain. That's the way they're supposed to work. Urban streams and areas that get too much water coming off them from the landscape, off roads and streams and roofs of houses, you end up eroding downward. The water never gets out of the channel, therefore the floodplain is removed, upland species move in, and you actually have taken away the functionality of the wetland. That is the real vision for restoration, especially in urban systems. And so we came up with this concept of anabranching. Anabranching is a new method of stream restoration. It refers to the diversion of water out of a single channel so that it can be spread across the floodplain. And that's the whole idea. Beavers do this all the time. And originally, historically in the United States, we had a large number of beaver populations. We had a lot of anabranching. In essence, what it is water comes in and you divert it to a wetland here, and then we have an outflow system that goes back into the stream. You can see this water down here, which is in the wetland cell that we created. Water moves into the floodplain, which is what you want. It seeps into the ground. It has contact with the wetland plants, contact with the soil. It moves slowly, and you get cleaner water. It's really putting these systems back the way it was when we had a lot of beavers in the 1700s and 1800s. Now at the outflow of the first cell. So here's the channel leaving the wetland cell. Not much flow today, it's very low. It goes through this weir over here so we can measure the actual volume of water. And this is again our water sampling equipment, this anabranching. It gives us a chance to look at water quality and changes due to these wetland cells. It's a new way of looking at it, but it's an old way if you look at it from the points of view of a beaver. This area here was excavated, it was forest, and then we created this area to hold the water and drop sediment. This was the first phase of swamp. This is an important project to improve water quality for over 2,000 acres of both Duke and the city of Durham. So it's a real partnership. Flow downstream past the golf course into New Hope Creek, and then eventually we flow into Jordan Reservoir. The function of this pond was to slow the water flow, back up the water behind this, and we can raise and lower the water in this 3 feet. So we wanted to see if we could affect the quality of the retention of the water back on the wetlands streams, which is way behind us. The water quality improved nitrogen by 75% in the first 3 years. This was the prototype, and now the university puts in bioretention areas and stream improvement wherever they can. Near the dam, you can see the dam there. There are actually 2 giant holes as a refuge for turtles and fish. We've also planted a lot of native species along the edge, including some cypress, which actually did originally grow in this area. So it's turned out to be a fantastic biodiversity restoration combination. Look at all the new species we have. We have kingfishers and mallard ducks and herons and blue herons. This is a really great birding area if you're an e-birder. A lot of people come here and add to their bird list. The American bittern, for example, has not been seen here in 75 years. So people came from all over to see the American bittern. Very rare in this part of the world, and it came and it was eating little crayfish. Student build bird blind in an area where we come to look at some of the species, and it's sort of protected. We don't clear out all this out, so you sort of peek through that and through the shelter. But this is where we have the American bittern. We have a number of waterfowl species that come here. We have up in those trees, there's a pair of hawks that normally soar around here. It looks weedy, but that's the way Mother Nature is. It's pretty much a native habitat. We have a typical Piedmont forest, and we're getting the swamp forest here. It would be something that would have been here 150 years ago before the forests were all cut. Wetlands restoration really helps the number of reptiles and amphibians. We had almost none here before because the water was not getting onto the floodplain. Now we've actually increased the number of amphibians and turtles by about 5-fold. It actually took about 3 years for that to happen. This is the Sandy Creek stream. This is the actual stream restoration that we're looking at. What used to be 10 to 12 feet deep is now only about 1 foot to 3 feet deep, so the water flows over the banks when you have a storm. You can see over here the last storm, you can see the water sitting in the wetland right across the way, getting treatment as it percolates through the soil. This is a key part of the project. We did about 6,000 feet of streams like this. University should be a model for this type of thing, to educate students but also improve water quality on the campus. It's an interesting way in which the campus itself and the Duke Forest is contributing to improve water quality for the city of Durham. It's been a great learning experience for students. We've had classes out here. They love coming out here. It's some of our, and that students actually helped design all these phases. A lot of my students have ended up going into jobs in consulting firms, state government, learning how to do restorations.